Hello everyone, today I'm going to talk about another aircraft crash landing incident, using it as an example to explain a rather interesting side topic or detail about flight dynamics and control. Now this will be mostly about the physics after a brief summary of the incident, however I should still start with a little disclaimer. Now this is again an incident where no one got killed or seriously harmed, so I don't think it's too inappropriate to talk about. However, it does involve terrorism with all the thematical baggage that comes with it, which I am not really qualified to seriously discuss about any further than stating my opinion that terrorism is bad. And while the crew did survive unharmed, this was only due to their absolutely incredible skills and competence as well as a little bit of luck. So really, this does involve quite terrifying ideas and situations, since as far as the crew could know at the time, they were going to die. So this does briefly involve pretty harsh topics, however in the end no one got harmed, so I will skip ahead to explaining the actual incident itself, which is commonly known as the DHL incident. And this happened in Baghdad 2003 during the war on Hussein, and DHL is a German cargo transporting company who managed to find some experienced yet risk-friendly airplane crews volunteering to fly civilian cargo airplanes in and out of military air bases in the crisis zone, providing postal traffic between the soldiers stationed there and their families back home. Now on the 22nd of November 2003, an Airbus A300 took off from Baghdad International Airport, which at the time was under military control, and started its flight back home. Now it was known at the time that paramilitaries may potentially fire at airplanes taking off from this airport, and thus the airplane started a very steep and fast climb, trying to minimize the chance of any attackers encountering the airplane. However, it is a civilian airplane, it is not designed for such maneuvers, it is mostly designed for efficiency, and so it didn't perform the maneuver too well. It climbed at its maximum climb rate, but that was still nowhere near the climb rate military cargo machines could muster, and it didn't have any countermeasures or defenses either. A few minutes after takeoff, the airplane was struck by a man-pad surface-to-air missile fired by paramilitaries from just outside the controlled area around the airfield, and that is where it gets really interesting from an aviation and physics perspective. Now, what happened to the plane was that it actually lost pretty much all control. The missile was a heat-seeking missile, relatively simple in design, and so given the common standard airliner design that the A300 followed, it obviously homed in on the engine. It didn't hit exactly the engine, and the engine is mounted under the wing, so it basically hit the wing tip or outer wing, and caused several kinds of damage of different severity and immediacy. Now first of all, there was of course aerodynamic damage. The wing itself was damaged and partially destroyed towards the tip, losing lift as well as balance, since the missile had hit the left wing. So the left wing was losing lift, the right wing didn't lose lift, so the plane started basically rolling to the left. However, this was very immediate, but not really that big an issue. It wasn't efficient anymore, but it still had enough lift to fly, and the drift was correctable. However, there was additional damage through the systems within the wing. Now for once there are fuel tanks in the wing, and now there was a fuel leak as well as a fire on the wingtip. Most dangerously though, the control system had been damaged, and the hydraulic systems were now all losing pressure. The A300 has three main hydraulic systems, but all of them failed, leaving the plane without any control. Now this caused a few other minor issues, but most importantly, you couldn't move the elevator, rudder, ailerons, flaps, or landing gear, which means the one way you usually control an airplane at all in the first place was lost, and the plane was uncontrollably tumbling around, oscillating in a sort of up and down wave where the plane starts descending, thus by gravity starts going faster and faster, the lift increases, so the plane starts ascending again, starts climbing, the speed decreases through gravity, the lift decreases, and thus the plane starts descending again. And without control, this didn't really stop. However, there was one way left to control the airplane, which was through throttle. The two really relevant control elements left in the cockpit were the left and right throttle stick, the A300 obviously being a very classic airliner design with two engines, one on the left wing, one on the right wing, and two throttle sticks to control the two engines separately, though they are usually locked together, but you can unlock them and you can control both engines separately. And it turns out with a lot of skill you can actually use that to regain full control of the airplane. Now the first thing they did was somewhat stabilize the plane. They adjusted thrust back and forth so that the airplane would fly a somewhat straight-ish line, and then the flight engineer, remember this was 2003 before full computerization, back when there were 3 crew members in your regular airliner or cargo cockpit, a captain, a co-pilot, and a flight engineer who did what nowadays basically the computer does. And there is of course a backup way of lowering the landing gear in every airliner if the hydraulics fail. The landing gear is built to be pulled up by the hydraulics and can then be released to essentially drop down by gravity and then lock into place by a spring mechanism. So there's literally a mechanical winch. The flight engineer would get the winch, would sit down on the cockpit floor, open a small hatch, attach the winch to the screw in that hatch, unwind the locking mechanism, and the landing gear would then by gravity fall down and lock into place safely. So the landing gear had been fixed with a backup, but the pilots still had to control and land the plane. Now keep in mind there's still the problem of the fuel leak and the wing being on fire, so they were under quite a bit of pressure to get down fast. On the other hand, this kind of control is pretty difficult. It's not standard training, and so the pilots had to do a few rounds of practice before they could use this way of control with enough precision to actually hit a runway. Now how exactly this works comes down to the geometry of the classic airliner design the A300 employs. You have two engines, left and right, mounted under the wings, which again are relatively low mounted on the fuselage, so the center of thrust is below the center of weight. Also aerodynamically the airplane is trimmed upwards, so you can essentially fly a straight line with lift countering gravity without employing control surfaces. So that means that both speeding up and increasing thrust, which of course go hand in hand, will pitch the nose of the airplane up and start climbing and increasing altitude, while reducing throttle and reducing speed will result in the nose starting to drop and the airplane diving downwards. So far so relatively simple. The left-right control gets a lot more complicated because airliners, they don't really turn like a car or track chassis where you just turn to the left or turn to the right by turning the machine itself leftwards and rightwards, and the machine has a tendency to go forward, and so this direction is now turned, but rather an airliner flies a curve by rolling to the left or to the right, so its lift is tilted slightly from the upwards direction and has a left-right component which accelerates the plane leftwards or rightwards, pulling it into a curve, and then aerodynamic stability will turn the plane along with that turn in flight path, along with some help from the rudder. Now of course an airplane fuselage has still some degree of lifting body capabilities. That means if you just turn a plane leftwards, it will slowly start also altering its flight path, but it's not really an effective way to fly a curve in an airliner. However, there are two other factors contributing here, one very small and simple, the other much more important and a bit more complicated. We'll start with the small and simple one. If the left wing, for example, moves forward faster than the right wing because the left engine is throttled up further, and the plane kind of shoves itself through an awkward curve, the left wing will produce more lift because it is going faster, and the plane will roll to the right as the left wing is lifted up higher than the right wing, and this will start a somewhat more effective right curve. But the much more important factor here is that modern airliners have somewhat swept wings. Now they're not delta wings, but they are swept backwards to reduce drag at speeds that are a significant portion of the speed of sound. Now that drag reduction itself didn't save anyone, but it also had a side effect that if the airplane turns relative to its flight direction, kinda does that awkward, uncontrolled turn shoving, the wings obviously turn with the airplane, so in that case the outer wing will essentially be less swept, while the inner wing will be more swept. And while the wing sweep does add overall efficiency by reducing drag, it does also cost lift. It reduces drag much more than it costs lift, so it's still more efficient, but it still reduces lift, and so the more swept wing will have a tendency to go downwards, while the less swept wing, the outer wing, will have a tendency to go upwards, since it now has more lift and catches more air as it's further stretched out relative to the flight direction. And that will initiate a roll and thus a normal airliner turn. It is therefore possible to control the classic airliner design without any actual airforce, just by throttling up the two main engines separately, and you can try this out yourself in a flight simulator, and I've actually done that myself. You can see a link of that in the info box, but I'm not a pilot, I'm just an amateur flight simmer, but still you can get a bit of an idea, I think, of how difficult that is. That has several reasons. Now, we've already handled that the turns are kind of awkward because you always start off-center, but it gets worse. First of all these controls are extremely laggy and delayed. First of all, you have to wait for the engine to spool up or down, then the plane slowly starts turning, but this isn't equivalent to pulling full back or pushing full forward on the elevator or rudder or aileron. It's more a very, very tiny impulse. Even if you throttle up or down fully to 100% and 0%, which you really shouldn't do if avoidable, that still isn't equivalent to 100% deflection on the airfoil. It's more equivalent to some 5% deflection. That tiny already delayed impulse then gets further delayed by the aerodynamics effects that actually make them work. After all, the pitch is only partially controlled through the engines themselves, and to most part actually through the flight speed. So if you throttle up or down the engine, of course the flight speed takes a while to accelerate or decelerate to the speed you intend. And again, if you control the flight speed by engine throttle, you might overshoot. The engine still has a bit of lag in its reaction time, and when you're decelerating and approaching the lower speed that you're trying to slow down to, and you push the throttle back up too late, you might get slower than you intended, and then you might get faster than you intended again. And if you're not trained in this, you might go up and down a bit uncontrollably. And since you can't change the aerodynamics of the airplane, you no longer have any control surfaces, you are bound to a fixed airspeed for any climb rate or sink rate you're aiming at, which isn't quite traveling speed, but still much higher than the usual speed you would use maneuvering towards a landing. So you can only do very shallow descents or climbs. Same for the curving, you can only fly very broad turns with a very long reaction time, and so it's all awkward and all difficult. And the crew did fly a few rounds, about 10 minutes, to practice and gain precise control over this type of airplane control. Also having to use it to correct the drift caused by the wing damage and the additional drift since there was a fuel leak. The center of mass changed since fuel was leaking out of the left fuel tank but not the right fuel tank. The center of gravity of the airplane started shifting further and further to the right, which they constantly had to correct. Now again, you can try this yourself in a flight simulator. I've tried it, but flight simulators are not perfectly accurate, and still with an intact airplane, with a lot of practice and a lot of luck and under calm weather and perfect conditions, I was able to somewhat line up a landing, but it really kind of sucked. And this crew was facing much worse conditions. But with a lot of skill they still managed to land. During the approach they encountered weather turbulences which threw them a bit off course, and they even managed to correct that out, but they did end up landing a little bit off center. And they didn't have any way to properly control it after touchdown either. They did engage thrust reversers to slow down as fast as possible, but they ended up veering off the runway through barbed wire and into an old minefield, which is where they did get a little bit lucky as they did not detonate any mines. They were recovered from this position and went on to report about their story, and their experiences actually helped making airline travel safer, Their gained knowledge was implemented into training courses, and it's now relatively normal for an airline pilot to have done a few such landings in a flight simulator just to gain that little bit of practice, so they're somewhat prepared if they ever get into a remotely similar situation and have to use this type of differential thrust-based control on an airplane that isn't designed for it for an emergency landing. Now I hope you enjoyed this little talk about flight dynamics and airplane control techniques without hydraulic systems. Despite the dark background of the incident, I based the explanation on as an example. If you have any questions about aerospace engineering, aviation, spaceflight or flight physics, I'm always open for requests. And as always, thanks for watching.